Folks, Segasonicfan here, and today I'm looking at repairing an electric tea kettle. These are always a little bit prone to breaking just because they take a lot of power, 1500 watts in this case, which is the maximum I think for most North American appliances, and they get really, really hot because they're boiling water, and that's the whole point of their existence. This one broke, annoyingly. All I did was you know what? I might have filled it past the max line. I filled it like up to here in boiled water to clear out my sink, and then I did it again. Filled water up to here to boil it again, and I heard a loud pop sound from the handle, which is where the AC switch is. So I'm guessing, I don't know, maybe a varistor, fuse, capacitor, something blew up. So I'm going to take this apart, see what's inside, hopefully help you folks out in fixing one yourself. General rule of caution, this uses AC mains. It uses 120 volts in North America. So dangerous, take extra precautions whenever you're working with main stuff. Double check all your work. Use gloves, all that kind of stuff. All right, more to come. Back here with the Zokop. What is it? Zokop. It's an interesting brand name. Electric tea kettle. And boy, have I found something I was not expecting, or rather the lack of something that I was expecting. And that is a fuse. This 1500 watt electric tea kettle that I bought off the Amazon, the dreaded Amazon, does not have the most basic protection necessary for a high wattage appliance like this. I couldn't believe it. Because I heard the pop sound and I was like, oh, that's just the fuse going bad. But there is no fuse, folks. This is crazy. I'm gonna get this working shortly, I'm confident, and I will know for sure, but I'm like 99.9% sure there's no fuse in here. So how the circuit works is... Oh, dropped a screw. The plastic, by the way, is like incredibly cheap, but I do love the fact that Phillips screws hold everything together, which I think is not in line with UL certifications, which this probably doesn't even have. Boy, this is a dangerous $30 tea kettle, $35 tea kettle. So how the circuit works is you have your AC mains comprised of the inner and outer ring here that go into the base, which has the plug that goes to your wall. From the outer ring, I believe, is this wire, which goes up to the switch. And the switch is just a simple, I believe it's one of these, it's a SPST, but it's also a thermostat type switch, I believe, because it does pop out when the temperature gets to be a certain temperature. So I guess it's got to be measuring temperature somehow. Yeah, I think from this metal plate in the lid is actually maybe it's using the plastic to heat up. I'm not sure, actually. That's a really good question. How is it measuring the temperature to pop out when it's done? How does it know when it's finished? Okay. That actually... Okay, I'm not sure how the switch itself pops out, but actually the thermostat's actually going to be down here. The mechanical thermostat makes a lot more sense. Anyway, that's one mystery to be solved a little bit later, but and unless there's a fuse in here, which there's no fuse. I can't see one. There's no fuse. Because it goes to the switch, right? Switch comes out to here, and then when you connect the switch, you're basically connecting these 2 points. And that goes to a 14 ohm resistor, which is your heating element, and that connects to the other line of the AC voltage input. What are these things going on here? We have 2 LEDs and a high resistance, resistor there, and I think maybe some other part. Maybe it's just a resistor. I'm not sure how they're doing that with AC for these LEDs, but I don't know what type of LEDs they are either. They could be AC. Yeah, they're probably AC LEDs. Is there such a thing? I thought LEDs always need direct current. Anyway, not sure how they're doing the LED thing, but if anyone knows, feel free to leave a comment. But yeah, there's just 2 LEDs, and I thought this was the thermal fuse at first, but no, it's just a resistor. It's a high wattage resistor for the LEDs. So I can't find a fuse anywhere in the travel of the circuit. And then I took apart the base thinking, oh, must be where the fuse is. And no, I found my problem, but certainly no fuse. And that is the problem. So there was no fuse, and so what happened is the wires here just kind of cooked from overcurrent, I guess just from using this twice in a row, for having a load past the max line. I don't know, like it shouldn't really do that, but they just, you can see here, they just completely cooked. And I'm not even sure these are rated, I guess they might be rated for 1500 watts, but sorry, let me get the camera on here a little better and zoom in for you all. Refocus here. There we go. Yeah, so you can see my black wire here is just it's looking real bad. All right, let me refocus this a little bit. Look at that. So what happens when I plug this in and measure it is I actually get about 50, 60 volts AC. So it's actually, it's got a connection, but it's just broken enough not to work. And then you can see the burn mark here too. So, I mean, fortunately, I never run this thing unattended. But if, you do, or you got kids running around and you leave this unattended to boil your water, hello fire hazard. Because there's no freaking thermal fuse. That is just mind-boggling. And look at that. It's even got a C certification. Whether or not that's accurate is one thing, but this literally should just not be sold, at least in North America. I don't think that's legal to sell a 1500 watt appliance with no fuse. So yeah, be careful what you buy, I guess, is the lesson here. I'm going to go and add my own thermal fuse. You can see the broken link there. And then I'm going to have to look into crimping this because this is going to be getting so hot that I don't believe I can just use regular solder. Hopefully this video is interesting and helpful. Feel free to do all the usual things that people ask the people to do. And yeah, I make these videos to help people repair general things around the house and video games and all that kind of stuff, things that aren't documented elsewhere. So yeah, have fun repairing, hacking, upgrading, all those good things. This is Segasonicfan, signing out. All right, back here with the tea kettle, and I've got the wires all repaired. I need to order a fuse, though. I don't actually have a 15 amp, super high current AC mains fuse on hand, unfortunately. So I'm going to order one and then upgrade this because it really, really needs it. But in the meantime, at least I've got it now back to like stock configuration, which is not safe. I am going to plug this into a nice APC surge protector, which is fused. I'm also only going to use this to cook about that much water for oatmeal until I get my fuse in the mail, and I'm going to watch it like every time it's cooking, it's boiling. So yeah, this is not a full repair yet, but just wanted to show how it should look, at least when it doesn't have a fuse. But if you own one of these, you absolutely must put a fuse inside. This is insane that they shipped this without a fuse. Can't believe it. I can't believe it got some kind of certification too, without that. And no doubt it's just a cost saving thing. But come on, like a fuse is like $1 at most. If you get like some really fancy one, probably more like 50 cents. Keep somebody's house from burning down. Seems like a good thing. This plastic, as I mentioned previously, it's very, very cheap, very easy to strip. So don't go too crazy with your electric screwdrivers. And it's super flimsy too. Look, it even gives you a warning. Do not immerse in water. What do you know? Don't put your electric tea kettle base in water. Maybe it's because they worry some people might try to clean it or something. I guess that makes sense. They try to put it in the dishwasher. I don't know why you would do that though. It's got an AC cable coming out of it. All right, so now I'm going to test this, and I'm going to test it using a isolation transformer, which you absolutely should do when you're doing this kind of stuff, because it is dangerous. And I'm not actually going to power it up on video here because my isolation transformer is not rated at 1500 watts.
That would be a very expensive isolation transformer. Mine's rated at about 100, but I can at least measure the AC mains before I take it in the other room and plug it into my surge protector and all that. And so yeah, just be careful when you're doing this. And speaking of which, I need to put on my gloves. And there's two contacts, one for the inner ring and one for the outer ring. And so, outer ring, inner ring. And if we look over here, voltmeter. You can see now it's getting a nice 120 volts AC, which is what it should be getting. Yay! So I'm going to go boil some water with this. I'm confident that it should be fine now, at least as far as stock. It's not fine for safety. I do have to install that fuse. So I'll order that as well. Have fun repairing, hacking, upgrading things, and learning about safety issues in products that really should be there. This is the electric tea kettle. Again, the brand is Zokop, but these are kind of generic. I think there's a lot of them around. And hopefully you learned something from this. This is Segasonicfan, signing out. Hey folks, so we're back here, and now we have installed a safety fuse, a much needed, absolutely necessary feature of any 1500 watt water boiling appliance. And it's this guy right here. I went ahead and left the heat shrink tubing a little bit loose. I don't want to risk heating this up too much and popping the fuse. Although I feel like I could probably do it if I did it really carefully. It's not really that necessary. Just went ahead and used this NTE 8181 thermal cutoff fuse, which is rated at 184 degrees Celsius max, and its operating current 15 amps, which is what you need because this is a 15 amp water boiler. So that's wired in to the hot line, which is the black wire. And I made sure to keep the wires like not touching each other. So if there's ever a failure state kind of similar to what happened in the future, you don't want to risk a short, which would be really bad because that would, you know, the actual coating on the wire itself melted, which is just ridiculous. But, you know, that's what the fuse is here for. Being a thermal fuse, it should break in that event and prevent that from happening ever again. So yeah, not the most complicated upgrade repair ever, but a very essential one and good to let people know about. I guess be really careful buying high wattage appliances off Amazon. Shrug. I don't know. I was just kind of shocked to find this was the situation and very, very easily could have started a fire. So yeah, be cautious, be careful. Hopefully this was helpful. Let me know in comments and stuff what you think. This is Segasonicfan, signing out.